All right, buckle up, because today we're diving headfirst into the world of Proxmox networking. And specifically, we're tackling a problem that I'm sure many of you have encountered. Those frustratingly slow download speeds in containers. It's like watching paint dry, right? You've got this awesome home server setup with Proxmox, maybe pfsense for routing, but those container downloads are moving slower than a snail in a traffic jam.
Yeah, it can be incredibly frustrating, especially when you know your hardware should be capable of so much more.
Yeah.
And it's not always obvious where the bottleneck is hiding.
Exactly.
Yeah.
And that's where this guide we're dissecting today comes in. It's like having a detective on the case, ready to help us sniff out those bandwidth gremlins.
Absolutely. And one of the first suspects it points to is, no surprise, sense. Specifically, those traffic shaping rules that we all love to tinker with.
Ah, traffic shaping. It's a double-edged sword, isn't it? Powerful, yes, but it can also cause chaos if you're not careful.
Exactly. The guide actually calls out a common pitfall we see: overly aggressive traffic shaping rules. You know, the ones that are supposed to prioritize your gaming traffic or video calls, but end up accidentally throttling your containers in the process.
Oh, I've been there. It's like accidentally putting your containers in the internet slow lane while everything else zooms past. So what's the solution? Just disable traffic shaping altogether.
Well, you could, but that's kind of like using a sledgehammer when you need a scalpel, right? The guide recommends a more surgical approach, fine-tuning those rules or maybe setting specific bandwidth limits for your container traffic.
So instead of completely disabling traffic shaping, we're aiming for a more strategic approach, ensuring those containers get their fair share of bandwidth without bringing the entire network to a crawl.
Precisely. Now, let's say you've given your pfsense configuration a thorough checkup. You've optimized those traffic shaping rules, but those downloads are still stuck in the slow lane. What's the next step in our investigation?
Well, according to this guide, it's time to pop the hood and take a closer look at those virtual network cards. You know, I have to admit, I often take those for granted. They're just there doing their thing in the background, right?
That's a common misconception. Those virtual network cards are just as important as their physical counterparts, and they can significantly impact performance.
So what's the magic bullet here? Do we need to buy some fancy virtual network cards? Is there a black market for those?
Haha, no black market required. The guide actually recommends a very specific type of virtual network card driver, VirtIO.
VirtIO, okay.
Ah.
And why is VirtIO the top dog in this scenario?
Well, it's specifically designed for virtualization, which means it plays much nicer with Proxmox and tends to offer better performance, especially compared to some of those older default drivers.
Got it. So it's like giving your container a performance upgrade just by switching to a more efficient driver.
Exactly. Now, for those who really want to push the limits, the guide also touches on a more advanced technique: PCI pass-through. Have you heard of that?
A PCI pass-through, vaguely. It rings a bell, but to be honest, it sounds a bit intimidating.
It can be, but it's worth understanding even if you don't implement it right away. Essentially, you're giving a virtual machine direct control over a physical network card on your Proxmox host, bypassing the virtual switch entirely.
So it's like giving that VM its own dedicated highway lane, completely separate from all the other traffic.
You got it. And as you can imagine, this can lead to some serious performance gains, especially for those bandwidth-hungry applications.
So if it's so great, why isn't everyone doing it? There must be a catch, right?
There are a few. First, it requires some more advanced configuration on your Proxmox host. And second, it can introduce some challenges if you ever need to migrate that virtual machine to a different host.
So potentially worth it for the performance junkies out there, but maybe not for the faint of heart or someone just starting out with Proxmox. Okay, so we've tackled traffic shaping and given those virtual network cards a tune-up. What other low-hanging fruit might be throttling our container's need for speed?
Well, this might surprise you, but the guide actually veers into Wi-Fi territory for a moment.
Wait a minute, Wi-Fi. I thought we were laser-focused on Proxmox here. What does my Wi-Fi setup have to do with my containers?
It's all about context. You see, many home server enthusiasts running Proxmox also rely on their home Wi-Fi network. And sometimes the culprit isn't Proxmox at all, but rather those pesky Wi-Fi gremlins we all know and love.
Okay, I've definitely had my share of Wi-Fi woes, but I'm still trying to connect the dots here.
Imagine this. You're seeing a noticeable difference in download speeds between your wired devices and those connected to Wi-Fi. And let's say, just for example, your Proxmox host itself is connecting to the network wirelessly.
Ah, I see where you're going with this. So the bottleneck isn't within Proxmox itself, but rather the Wi-Fi connection that the Proxmox host is relying on. It's like having a super fast car stuck behind a slow-moving truck on a single-lane road.
Exactly. And it's easy to overlook those external factors when you're so focused on optimizing the virtual environment itself. The guide actually recommends some classic Wi-Fi hygiene, updating firmware, checking for signal interference, those sorts of things.
It's like giving your Wi-Fi network a good old-fashioned tune-up. Sometimes, the simplest solutions are the ones we tend to overlook. But let's play devil's advocate for a moment. What if I've optimized my Wi-Fi to the max? My signal strength could power a small city, and those container downloads are still crawling along.
Then it's time to bring out the big guns, the diagnostic tools that help us pinpoint those bottlenecks with surgical precision. And in the world of networking, those tools often come in the form of command line utilities.
Ah, yes, the command line, where cryptic text meets powerful functionality. What are we summoning from the depths of the terminal today?
Two tools in particular, iPerf3 and speed-dist-cli. Think of iPerf3 as a network speedometer. It lets you measure the raw bandwidth between different points in your network.
So if I'm seeing a speed difference between, say, my main computer and a container, both downloading from the internet, I can use iPerf3 to figure out if the slowdown is happening within the Proxmox environment itself.
Exactly. You can test between your Proxmox host and your router, between containers, even between a container and a specific device on your network. It helps you isolate the variable, so to speak.
Love it. And what about speed test clay?
Speed-test-cli is essentially the command line equivalent of those speed test websites we all use. But in this case, you're running it directly from your containers, which gives you a much clearer picture of their actual internet speeds.
So no more guessing games or relying on gut feelings. We can see the cold, hard numbers.
Precisely. Now, before we get too carried away with our network forensics, there's one more common culprit we need to address, the infamous MTU setting.
Ah, yes, the MTU, or maximum transmission unit. It sounds so technical, so alluring, like tweaking it could magically unlock some hidden speed reserves.
If only it were that simple. While increasing the MTU can sometimes improve performance, we're talking about sending larger packets of data at once, it can also backfire if your entire network isn't configured to handle those larger packets.
So it's like trying to cram a giant suitcase into a tiny car.
Yeah.
It's either not going to fit, or you're going to spend so much time forcing it in that it would have been faster to just get a bigger car in the first place.
Exactly. The guide's advice. Unless you're absolutely certain that your entire network, from your modem to your router to your Proxmox host and everything in between, can accommodate a larger MTU, it's best to stick with the defaults.
Okay, I'm putting away my MTU tweaking toolkit for now. But speaking of tweaking, let's shift gears for a moment and talk about a curveball the guide throws our way. Unify controllers. Now, I know, we're deep in Proxmox territory here, but why are we suddenly talking about Unify?
Because, believe it or not, your Unify setup could be subtly impacting your Proxmox performance.
Really? How so? I thought those two were separate universes.
They usually are, but here's the thing. The Unify controller software, which many of us use to manage our Unify networks, doesn't actually need to be running 24/7 for your Wi-Fi to function properly.
Okay, seriously. I've been leaving that thing running all the time.
You're not alone.
Yeah.
It's a common misconception. And the guide suggests that if you're really trying to maximize performance on your Proxmox host, consider shutting down the Unify controller container when you don't need it.
So it's like reclaiming those precious system resources and giving them back to Proxmox, potentially giving your containers a little performance boost in the process.
Exactly. It's a low-risk experiment worth trying. And if you need to access the controller to make changes, you can always spin it back up temporarily.
Easy enough. And, this little tidbit about the Unify controller actually segues nicely into a broader point the guys makes about striking a balance between using containers and full-fledged virtual machines for certain tasks on your Proxmox server.
Ah, yes, the age-old debate. Containers versus VMs. It's a classic for a reason.
It is. And when it comes to performance, especially for network-intensive tasks, this guide doesn't shy away from recommending a full-fledged VM for those critical services, even if it seems a bit counterintuitive in our container-obsessed world.
It's about using the right tool for the job. And sometimes that means recognizing that a dedicated VM with its own dedicated resources is the best way to ensure a service runs smoothly and doesn't negatively impact the rest of your Proxmox environment. Think of it like this. A container is like sharing a highway with everyone else, while a dedicated VM is like having your own private express lane. No traffic jams, no unexpected detours.
That's a compelling analogy, and it makes a lot of sense. We're talking about those core networking functions, the bedrock of our home server setups.
Precisely. Things like your firewall, your VPN server, even your DNS server, these services might benefit greatly from the dedicated resources and isolation that a VM provides.
So instead of cramming those essential networking services into containers, we're giving them their own private island, so to speak, with all the resources they could ever need.
Exactly. It's about recognizing that sometimes a little extra overhead in the form of a dedicated VM can actually lead to smoother sailing for your entire network.
It's like saying, hey, these services are too important to share, they get their own VIP lounge. But let's say, for the sake of argument, that I'm committed to my containers. I want to squeeze every last bit of performance out of them. What else can I do?
Well, in that case, it's time to roll up our sleeves and really dig into the nitty-gritty of how data flows through our network. The guide talks about understanding your network topology.
Network topology. Okay, that sounds a bit intimidating. Am I going to need a degree in cartography for this?
Not quite. It's actually simpler than it sounds. Think of it as creating a map of your network, a visual representation of how all the pieces fit together.
So we're talking about tracing the path those data packets take, from the moment they enter my house, through the modem, all the way to their final destination, which, in our case, is often a container running on our Proxmox server.
Exactly. You've got your modem, your router, maybe some switches in the mix, your access points, and of course the Proxmox server itself with all its virtual inhabitants. Map it all out.
And the purpose of this map is
To help you visualize those potential bottlenecks, imagine you're testing the bandwidth between your modem and your router, then between your router and your Proxmox host, and finally between the Proxmox host and a specific container. By comparing those results, you can start to see where the slowdown is happening.
It's like those detective shows where they use a string map to track the killer's movements. We're basically doing the same thing, but with data packets.
Exactly. And sometimes the culprit is hiding in plain sight. We tend to focus so much on the virtual networking within Proxmox that we forget to consider the possibility that the bottleneck might be the Proxmox host itself.
Wait a minute. Are you saying that the server running Proxmox, the heart of the entire operation, could be the one holding things back?
It's more common than you think. Remember, even the most powerful servers have their limits. Think of it like trying to run a marathon with a pebble in your shoe. You might have all the endurance in the world, but that one small annoyance can bring you to a grinding halt.
So we're talking about the Proxmox host's hardware being the bottleneck. Not enough CPU power, RAM, maybe a slow hard drive.
All of the above. If your CPU is constantly maxed out, your RAM is full. Or those containers are trying to read and write data to a slow, spinning hard drive, that's going to impact network performance, even if your virtual networking configuration is absolutely perfect.
That makes perfect sense. It's like having a super fast car, but you're trying to drive it on a dirt road full of potholes.
Precisely. The guide emphasizes the importance of monitoring your Proxmox host's resource usage. Check those CPU loads, keep an eye on RAM usage, and if you're still rocking a mechanical hard drive, maybe consider upgrading to a nice, speedy SSD. You might be surprised at the difference it makes.
So before we get lost in the weeds of virtual network settings, it's always a good idea to make sure the Proxmox host itself is in tip-top shape, both on the hardware and software fronts.
Absolutely. Now, speaking of software and those finer points of virtual networking, let's circle back to those virtual network cards for a moment. We talked about the importance of using the VirtIO driver, but there are a few other settings that can influence performance.
Okay, I'm ready to dive deeper. What kind of settings are we talking about here?
The guide specifically calls out the hardware offload settings. These settings essentially control whether certain networking tasks are handled by your CPU or offloaded to your network card. In theory, offloading sounds great because it frees up your CPU to do other things. But here's the thing. In a virtualized environment like Proxmox, this offloading can sometimes create conflicts or introduce latency.
Wait, so letting my fancy network card handle more of the work could actually slow things down?
It seems counterintuitive, but yes, it's possible. It all comes down to compatibility. The compatibility between your network card's drivers, your Proxmox host configuration, even the specific operating system running inside your container. The guide recommends experimenting with these hardware offload settings, both on the host and within your container, to see if tweaking them improves performance. It's a bit of a balancing act, really.
It's like trying to find the right balance of delegation. You want your network card to handle the things it's good at, but you don't want to overload it and create a bottleneck in the process.
Exactly. Now, while we're in the virtual networking control room, let's talk about another crucial component: The network bridge.
The network bridge. Okay, sounds like we're building some serious virtual infrastructure here.
Think of the network bridge as the central hub, the grand connector that allows all your virtual machines and containers to share your Proxmox host's physical network interface and communicate with the outside world. It's the gateway between their virtual world and the real world, so to speak.
So it's the VIP entrance and exit point for all our virtual network traffic.
Exactly. And the way you configure this bridge can significantly impact performance. The default settings in Proxmox are usually a good starting point, but there are a few key settings that, if tweaked carefully, can potentially squeeze out some extra performance.
I'm all ears. What kind of tweaks are we talking about? Give me the good stuff.
One example is the multi-queue option. If your Proxmox host has a multi-core CPU, enabling this option allows the network bridge to distribute those incoming and outgoing network packets across multiple CPU cores, rather than bottlenecking on a single core.
So we're essentially parallelizing the network processing to take full advantage of those extra CPU cores.
Precisely. There are other settings you can fine-tune as well, but the guide stresses that it's important to do your research and understand the potential implications before making any drastic changes to your network bridge configuration. We don't want to accidentally create a virtual traffic jam in the process.
Right, it's all about calculated risks when you're optimizing for performance. Now, before we wrap up this deep dive into Proxmox networking wizardry, there's one last piece of the puzzle I'd like to address. Resource allocation within Proxmox itself. We've talked about having a powerful enough host and optimizing the network, but what about making sure each container has enough resources to thrive?
An excellent point. It's not enough to have a fast network if your containers are starving for resources. It's like having a sports car with a sputtering engine. It won't matter how good your transmission is if you can't get the power to the wheels.
So even if my Proxmox host has plenty of CPU cores and RAM, if those resources aren't allocated properly among the containers, I could still run into performance issues.
Exactly. It's all about finding that balance, ensuring no single container is hogging resources and inadvertently starving the others.
So what's the best way to ensure everyone is playing fair and getting their fair share of the Proxmox pie?
That's where Proxmox built-in resource management tools come in handy. You can set limits on how much CPU time, RAM, and even disk I/O each container can use.
So it's like setting up some virtual guardrails, making sure no single container veers off course and crashes the party for everyone else.
Exactly. By setting these limits, you create a more predictable and stable environment where each container can access the resources it needs without negatively impacting its neighbors. It's about fostering a sense of community even within your virtualized world.
That's a great way to put it. Now, I'm starting to see the bigger picture here. Optimizing Proxmox container bandwidth isn't just about tweaking one setting or focusing on one specific area. It's about understanding the intricate dance between hardware, virtual networking, resource allocation, and even external factors like your Wi-Fi setup.
You've hit the nail on the head. It's a holistic endeavor, a symphony of optimization where each instrument plays a crucial role in achieving that harmonious high-bandwidth performance. And like any good orchestra, it takes practice, experimentation, and a willingness to fine-tune each element to achieve that perfect sound.
So, for our listeners who are ready to tackle their own Proxmox performance puzzles, what's the most important takeaway from all of this? What's the one thing they should keep in mind as they embark on this optimization journey?
You know, it's really tempting to search for that one magic bullet, that one setting that'll instantly boost your speeds. But the truth is, optimizing network performance in a virtualized environment is more like solving a mystery. It's rare to find one single smoking gun. It's more about carefully examining each piece of the puzzle, understanding how they interact, and then eliminating possibilities one by one.
We've definitely covered a lot of ground today. We've talked about taming those traffic-shaping gremlins in PARPs. We've explored the world of virtual network cards. And we even touched on the idea of giving those critical networking services their own dedicated VMs, like creating a high-security wing in our Proxmox Fortress. But is there anything else? What other wisdom does the guide offer for those who want to take their Proxmox game to the next level?
Well, it actually circles back to a point we touched on earlier. Remember how we talked about the possibility of the Proxmox host itself being a bottleneck, even if you have a fairly powerful server?
Right, the idea that even the mightiest machines have their limits.
Exactly. Well, the guide takes that concept a step further and poses a somewhat provocative question. What if, instead of trying to squeeze every last drop of performance out of a single Proxmox server, we rethink our entire approach to home server architecture?
Okay, now you've got my attention. Rethink our approach. What does that look like in practice?
The guide suggests this. Imagine dedicating a separate physical machine entirely to those critical networking functions. No virtualization, no containers, just a lean, mean, purpose-built networking appliance.
So instead of having our firewall, VPN, and DNS running as VMs or containers within Proxmox, we'd have them running on their own dedicated hardware. Interesting. But wouldn't that add more complexity to our setup? I mean, now we're managing multiple physical machines instead of just one?
It could, and that's why the guide presents it as more of a thought experiment than a one-size-fits-all solution. But think about the potential benefits. First, you're segmenting your network even further, creating a clear separation between your core networking functions and your general-purpose computing environment, which, by the way, can enhance security because you're isolating those critical services from any potential vulnerabilities in your other workloads.
That makes sense. It's like having a separate, secure building for your network's most sensitive operations.
Precisely. And second, by offloading those demanding networking tasks to a dedicated machine, you free up resources on your Proxmox server, potentially giving your virtual machines and containers a little more breathing room to do their thing.
So it's all about striking that balance, right? Giving each part of your setup the resources and attention it deserves.
Exactly. Now, this approach might not be for everyone. It requires additional hardware, maybe a bit more technical know-how to set everything up, but it does highlight the flexibility that makes Proxmox so powerful. You can tailor it to your specific needs and constantly experiment with different configurations to find what works best for you.
And that's the beauty of this whole journey, isn't it? We're constantly learning, exploring new possibilities, and pushing the boundaries of what's possible with our home server setups.
Couldn't have said it better myself.
Well, on that note, I think it's time to wrap up this deep dive. To all our listeners out there, if you're feeling inspired to tackle your own Proxmox container bandwidth challenges, just remember, you're not alone. This community thrives on knowledge sharing, experimentation, and of course, a healthy dose of troubleshooting tenacity.
And who knows, maybe those sluggish downloads are just the catalyst you need to unlock a whole new level of understanding and optimization for your Proxmox server.
Well said. That's a wrap on another enlightening deep dive. Until next time, happy networking, everyone.